Alright, today we're going to be talking about thrombosis. Thrombosis is the coagulation of your blood, so the forming of a blood clot. In particular, we're going to be talking about the intrinsic pathway. There are many other pathways that can lead to the same exact result. So to start, whenever there is a tear in your blood vessel wall, the underlying collagen is exposed. And this exposed collagen causes platelets to be really attractive to that and bind, and this releases ADP. This release of ADP causes more platelets to flood to that area and kind of fill up the gap. After all the platelets have kind of stuck together and filled up that gap, they are activated, and that activation causes the surface of them to be highly negatively charged. This negative charge then causes a coagulation cascade to occur. This coagulation cascade, we're going to go into kind of great detail about this now. So to start, the coagulation factor 12 is extremely attracted to the negative charge on those platelets and be activated by it. The activation of factor 12 can then go and activate factor 11. The activated factor 11 then activates factor 9. Activated factor 9 and activated factor 8, which is activated by something called thrombin, which we'll go into later. They're going to combine along with phospholipids and calcium to activate factor 10. The activated form of factor 10 then activates factor 5, which is also activated by thrombin. Factor 5, along with platelets factor 3, help to convert prothrombin into thrombin. To start, thrombin is very important for this entire process of forming a blood clot because it's going to activate several different things. Thrombin activates more factor 5 and 8, which causes a positive feedback loop to occur. Thrombin will also convert fibrinogen into fibrin, and that is very important for the formation of a blood clot. Alright, so now we're going to go into the conversion of fibrinogen into fibrin. So thrombin is a very important molecule within this process because it helps facilitate the cleaving of fibrinopeptide A and B off the E region of fibrinogen. This then activates that and causes the D and E portions of fibrinogen to bind together and form a network called fibrin. Multiple fibrin molecules can then come together and make a mesh around the platelets to form a tight seal and form that blood clot. The creation of the fibrin mesh is very important for the overall stabilization of the blood clot. It does this by trapping in platelets and red blood cells and prevents them from degrading. This entire process is heavily regulated for obvious reasons, but we have evolved science to have the ability to regulate this for people. In particular, one of the molecules that we'll use for somebody who is going through an active heart attack or stroke is heparin. And what heparin does is it helps regulate the coagulation cascade. Now, our body doesn't just create blood clots, but it also degrades them. And it does this through the fibrinolytic pathway. This pathway produces a protein called plasmin that will then help break down fibrin into different fibrinogen fragments and fibrin fragments. And this leads to the degrading of a blood clot. One of these products from the degradation is called D-dimer, which is two D regions of the fibrinogen bound together into a dimer. D-dimer is one protein easily examined within the medical field as an indicator for blood clots, since it does show that that patient is actively trying to degrade a blood clot. Now, today we talked about thrombosis and one of the ways your blood coagulates due to damage. Now, that's all we have for today. the next time you get a paper cut due to all the studying that you're doing, think about thrombin and thank it.